Section 6.4, vectors and dot products. We're going to be finding the dot product of two vectors and use the properties of the dot product to find angles between two vectors. First thing is, what is the dot product? Well, we've done addition and we've done scalar multiplication so far with vectors. The dot product of two vectors is given by, I'm going to highlight this right here, is given by, so when you take the dot product of vector u and vector v, it's not multiplication, it's the dot product. We've got to be clear on this. So we're not just going to multiply two vectors together. It's the dot product. You take the first two components and multiply them. You take the second two components and multiply them, and then you add those two together. The result is scalar though. All right, so we're not going to get a vector back from the dot product. It's just going to be a value or a number. Okay, so let's go ahead and practice just a couple of these to show you how to find the dot product. So to find each dot product, I've given you basically three different types of forms in terms of vectors that we've talked about. So on the first one, this is your component form, 3, 7 and 5, 2. Once again, this represents the dot product, not multiplication. So the dot product of these two vectors would be 3 times 5 plus 7 times 2. And that would be 15 plus 14, which is 29. So the dot product of those two vectors is equal to 29. B, the dot product of vector u and v, u being u equaling negative 4, 2, and v equaling 5, 10. So they are written in component form. So once again, we'll multiply the first components together, negative 4 times 5, plus the second components get multiplied together, 2 times 10, negative 20 plus 20 is equal to 0. And once again, scalar. And then on C, we're now going to use our linear combination that we learned in the last video. U is 2i minus 3j. V is equal to negative 5i minus j. So if we do the dot product, it's going to be 2 times negative 5. So those first components again, plus negative 3 times negative 1. So it'll be negative 10 plus positive 3, which will equal negative 7. So you can see our answers can be positive, negative, or 0 with the dot product. A couple properties of dot products. It is commutative. You can take the dot product of vector u and v, or the dot product of vector v and you will get the same scalar. It is also distributive. You can take the vector u and do the dot product of v plus w, and that would equal the dot product of u and v plus the dot product of u and w. Also the identity property, if you take the zero vector, or not times, once again the zero vector, the dot product of the zero vector and v, you will get the zero vector back. And then scalar, where you have the scalar value of c times the dot product of u and v. That can also represent the scalar u, or the scalar c, sorry, times the dot product u and v, or you can do the dot product of vector u and c times v. So there's a couple different ways you could look at that. And then the last one is the dot product of the same vector is equal to the magnitude squared. Okay, so the dot product of the same vector is equal to the magnitude of that vector and squared. So let's take a look at that one. Vector v sub 1 and v sub 2. And if we do the dot product of that same vector, that would be v sub 1 times v sub 1 plus v sub 2 times v sub 2, which would be v sub 1 squared plus v sub 2 squared. So that would be the dot product of v in itself. Alright, let's look at the magnitude. So the magnitude of v, alright, would be equal to the square root of v sub 1 squared plus v sub 2 squared. Alright, so go back to what this property is. The dot product of the same vector would be v sub 1 squared plus v sub 2 squared. is equal to the magnitude square. So if we square the magnitude, which we hadn't done yet, but if we square this, that would give us the magnitude of vector v squared is equal to, and then the square root, and the square will cancel. So look what you're left with. Exactly the same thing. So the dot product of the same vector is equal to the magnitude squared. Let's go ahead and use the properties of the dot product. So we're going to find each dot product and then ask the question, is the result a scalar or a vector? So we're going to use the properties we just kind of looked at. The first one is the dot product of u and v times vector w. So we'll do the dot product first. That'll be negative 4 times 5. So we're multiplying the first components, plus 2 times negative 3, multiplying the second components, and then this will be multiplied by vector w. So this would be negative 20 plus negative 6, and that'll be negative 26 times vector w, which is 1 comma negative 3. So it's a scalar times a vector now. So that would be a vector negative 26 and 78. All right, and so that would represent a vector in this case. So the dot product was a scalar, but then we took a scalar times the vector, so we got a vector back. On B, what do we have? We have the vector u, and then we're going to do the dot product to the scalar 2 times the vector v. So we have vector u, negative 4, 2, and then the dot product of 2 times vector v, which is at 5, negative 3. So once again, vector u, and then the dot product, we're going to do the scalar though, 2 times vector v would be 10 comma negative 6. And then we have the dot product of two vectors, so we multiply the first components, multiply the second components, and add them together. So that would be negative 40 plus negative 12, which will be negative 52, and that would represent a scalar. It is not a vector. We're taking the dot product of two vectors, so that's just going to be a scalar. So there's just a couple of problems dealing with the properties of the dot product. So the dot product and the magnitude. So if you take a look, we did this one a little bit earlier in the property, something very similar to it. So if we do the dot product of the same vector, we will get 3 times 3 plus 2 times 2. So 9 plus 4 would be 13. If we do the magnitude of vector v, that would be 3 squared plus 2 squared, which would equal the square root of 9 plus 4, which is the square root of 13. So the magnitude of a vector is equal to the square root of its dot product. Or, from earlier, we said that the dot product of the same vector is equal to the magnitude of that vector squared, which once again the same thing. This would be 13, and then if you square the square root of 13, you get 13. So kind of the same idea that we had done before with the other properties from the beginning of the lesson. And so the last thing we're going to look at in this video is the angle between two vectors. How do we find the angle between two vectors? Well, we had to understand and to be able to find what the dot product was. So if theta is the angle between two vectors, so you can see from the picture, vectors u and vectors v, then this formula will allow us to find the angle between the two vectors. So it would be the dot product of vector u and v divided by the magnitude of the product of a vector u and v. Okay, our angle is going to be somewhere between 0 and pi, including 0 and including pi. And so example 3, we're going to find the angle between the two vectors. We'll round our answer to the nearest tenth. So we have vector u at negative 4, 2, and vector v at 3, 2. We're going to find the angle between those two vectors. So we have cosine of the angle, which is what we're trying to find, is equal to the dot product of negative 4, 2 and 3, 2 divided by the magnitude of each of those. So that'll be the square root of negative 4 squared plus 2 squared times the square root of 3 squared plus 2 squared. So if you want to kind of do these three parts separately and then kind of put it all together, that's fine. So you can find the dot product, you can find the magnitude of u and the magnitude of v, and then kind of plug those in and see what we have. So I'm going to kind of do that off to the side. I think it might be a little bit easier. So the dot product of u and v would be equal to negative 4 times 3 plus 2 times 2. So that's negative 12 plus 4, which would be negative 8. So the dot product is equal to negative 8. So that's the first thing. Then I'm going to find the magnitude of vector u. So that's the square root of negative 4 squared plus 2 squared. So that's equal to the square root of 16 plus 4, or the square root of 20. And I'm actually going to leave that as the square root of 20, and I'll explain why. And so that's the next thing that we needed. And then now we need to find the magnitude of vector v. So that would be the square root of 3 squared plus 2 squared, which is 9 and 4. So that's the square root of 13. So that's the third piece of the information that we're looking at. So let's go back up to the equation that we're going to use, the formula. So cosine of theta, theta is what we don't know. The dot product was negative 8. The magnitude of u was the square root of 20. And the magnitude of v was the square root of 13. Now, we could simplify this and rationalize it and everything else that we typically do. But remember, that's not our answer. Our answer is the angle. And so what we want to find is we want to find the arc cosine of theta of this value, whatever negative 8 divided by square root of 20 square root of 13 is. That's going to give us our angle of theta. So when we plug this in the calculator, we're going to use the inverse of cosine to figure out what that angle is. So that's what you can plug in the calculator. Now you could simplify this and do all that, and if you simplify it, you'll get let's see. So if I simplified it, I think I got down to negative 4 square roots of 65, and then you could rationalize the denominator and everything else. And like I said, but I wouldn't do that. I would just plug that into your calculator and then round it to the nearest tenth in this case. So we get 119.7 degrees if you are in degrees, or if you are in radians, it would be 2.1 radians. Okay, and I believe the textbook on this one does it in degrees, but either one, 119.7 degrees or 2.1 radians is the angle between the two vectors. And remember, we're supposed to be somewhere between 0 and pi, or 0 and 180 degrees. And so that's it for vectors and dot products. So once again, there's definitely a couple things you need to know here in terms of the properties and finding the dot product. You have that formula to know. You also have the angle between the two vectors formula to also know.